What is up, everybody? Welcome to another SAT prep video, and today we're going to be focusing on algebra. It's almost surprising how basic some of these algebra problems are. I'm talking like jean jackets, white camis, black leggings, some Chuck Taylor algebra problems here. But really what I find is that some of the most basic stuff is kind of what trips us up. Most people taking the SATs haven't really seen basic algebra since they were like 12. Today we're going to go over those algebra problems, and I'm going to show some tips and tricks for conquering the SATs.
Let's go beast mode.
First thing I do when I see this problem, I see right away what they want you to do. They want to know, can you combine like terms? And so what I'm going to do here is I'm just going to look at all the pieces of junk and then put that junk together. So let's see what junk we got. I highlighted the pieces of junk. We got 3x's plus 1x plus 1x plus 1x. So it's 3 plus 1, which is 4. 4 plus 1, 5. So we had 3 plus 1 plus 1 plus 1. Minus 3 minus 2. So this looks like negative 3 plus negative 2. This is a negative 5. It is equal to plus 2x. And from here, all we have to do is solve. So subtract 2x from both sides. What it comes down to is this is a 3-step equation with variables on both sides. Really nothing to it. This question, which is why I say like this question is really just asking you, can you combine like terms? Because if you can't, then you can't solve this problem. But you can, because it's easy. Just look for the junk, put the junk together. Speaking of junk, all this stuff up here is just trash. Like, I honestly don't care what any of this says. It's really just there to confuse me. This is just an equation that's solved for E. And down here it says, which of the following correctly gives P in terms of EOM? This is basically saying, like, do you speak math? Do you know what it means to put P in terms of? P in terms of means P equals something. So what we need to do is get P by itself. It's really like P's the person you like, and you're trying to get him alone, get him to the movies, take him to dinner, right? So what I'm going to do here is, so here's my equation. What do we want? We want P alone, so I'm just going to put a box on it. Put a bow on it. We're solving for it. We're looking for it. We're cooking for it. We're making it think that we're better than we actually are, at least for a little bit, until they find out who the real me is, or the real us are. Anyway, the thing we gotta do is get this 6 out of here. Because this divided by 6 times 6, these are inverse operations. You have to be able to recognize that this whole fraction bar means that this piece of trash up here divided by this number. Division is fraction bar. Opposite of division is multiplication. And what we do to one side, we have to do the other side. So I'm multiplying 6 on both sides. These two cancel out. And again, I'm looking for P. I'm looking for P. So I'm just consciously making the effort. I'm putting a box on it. I'm putting a bow on it. That's the one that I want. I'm going to subtract O from both sides. I'm going to subtract minus 4m from both sides. And what am I left with? So which one of these down here does it look like? And our answer is A. This is basically saying, like, can you solve for a variable? As well as, do you speak math? Do you know what it means to put something in terms of something else? Oftentimes we'll see this as an inverse function. Something like that. It's just an inverse. So here we're looking to invert this in terms of P. You don't need to know this. Another problem where they want to know, do you speak math? What is the solution set for the equation above? What that means is, A would be that x is equal to negative 1. And for C, it would mean that x is equal to negative 1 and x is equal to 5. Or x is equal to 5. You would have what we call an extraneous answer. With that out of the way, let's just go ahead and solve for x and see which one of these is possible. So first thing we got to do here is get the junk by itself. My junk right here is the square root of 2x plus 6. This is disgusting. It's gross. It needs to be alone. You know, plus 3 minus 4 is minus 1. And here what we need to do is we need to get rid of that square root. Square root's got to go. What we do to one side of the equation, we got to do to the other side. Squares and square roots cancel out, so I like to actually strike them through. Remember, exponents don't distribute. It's not what they do. It's not what happens. It's not in their wheelhouse. It's never going to happen to them. That's just not what they do. Get rid of that distributive property of exponents out of your mind for actually ever. When something is squared, it means it's multiplied by itself twice. So here, little Peter Cottontail, x minus 1, I'm just multiplying it by itself twice. So once, twice, not thrice, but twice. And now I'm going to do the distributive property, or as we call it often is the FOIL method. So first, outer, inner, last. Now I'm just going to set this equation equal to 0. And here we have a pretty easy factorable quadratic. Factors of -5 that add up to -4. Factors of this that add up to that. Factors of -5 that add up to -4. Factors of -5 are going to be 5 times -1 or -5 times 1. Which one of these factors add up to -4? That one does. So how this factors is x minus 5, x plus 1, and now we have two numbers multiplying together that equal 0. Two numbers multiplying together that equal 0. So what is anything times 0? It's 0. That means that either this is equal to 0 or this is equal to 0. Something minus 5 is 0. What number is that? Well, it's 5. Something plus 1 is equal to 0. What number is that? -1. Now let's go and see which one of these values we have. Oh, look, it's C. Oh, wait a second. What I'm going to do is plug these values in because the square root has a really specific stipulation. So let's try x is equal to -1. Let's see which one of these values works. What? Wait a second. This isn't true. That's not true. 6 isn't equal to 4. That's not true. 6 isn't equal to 2. That's why you need to check these. This is called an extraneous answer. Let's check the other one. One's true. So here we have is that our answer is actually x is equal to 5. And the reason x is equal to -1 didn't work is because it was actually an extraneous answer. These must be checked because you just have to check these. Every time you're dealing with a square root, because they have special graphs, because we don't do square roots of negative numbers, square root graphs oftentimes look like this, or they'll look like this. But what they don't have is often negative values. It's true that you can have some negative numbers in the graph. However, not many of them contain a lot of negative numbers in the solution set. So right away when I saw that -1 was in the solution set, I was curious. I was thinking, I don't think so. But even if you don't remember the graph, just remember that whenever you're dealing with square roots, that there's square root of -5 is undefined in the real numbers. And right away I'm thinking to myself, I'm suspicious of any negative answer in that solution set. Thus, everything must be checked. Check, 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 checks. Checks in the mail. All right, so here we have a problem that a lot of people probably forget how to do. This is something you see in Algebra 1, probably something that most of you haven't done since middle school. This is a system of equations. What I like to do here is I see this right away. I know I always say that. I'm a math teacher, so. But I see it right away. Here we have 220 people went on an overnight camping trip, 60 tents. So right away I see we have two different type of units that I'm dealing with here. But then some tents held 2 people each. The rest of them held 4 people each. How exactly many were there 2-person tents? Okay, so right away, I'm thinking of systems of equations, and I'm going to set this up as systems of equations first, but also, for some of you who are number savvy, you don't have to set up anything. You can get this just by thinking through this. But I'm going to fall back on algebra because, again, this is an algebra review. Let's see. I'm going to make an equation, and I'm going to do people plus people is equal to people. This is going to be my total of people. So here, a group of 220 people. This is the total people. How many people were there? There was a total of 220 people. Well, let's see. We have 2 peoples here. So how about this one come first? So it's X. And then we have 4 people here. So I'll do that one as Y. Notice I'm just taking all the people and I'm putting them into an equation. 2 people plus 4 people is equal to the total amount of people. Now in tents it's actually pretty easy because we know that there's going to be some amount of people in each tent. But we know that there is total 60 tents. And this is a very, very additional way to set up these problems. This is basically basically how they all look. There's another way that you might see these, but this is like the most common. And the reason they do this is because for these types of problems, you actually don't need to set up the problem to figure this out. You don't need to use this equation, but I will. I'm going to multiply the entire equation by -2. That way, I can do the elimination method, the eliminators. So these x's are eliminated. 4y's minus 2y's is 4y's. 4y's plus -2y's is 2y's. 202 plus -120 is 82. Then now just divide both sides by 2. I is equal to 41. Got 1. So let's remember we had x plus y was equal to 60. So y is 41. So what do we got to do here? Subtract 41 from both sides. We have x is, and notice what came first, x or y. So here we did our x's came first, right? X comes before y. So whenever we're doing these, I'm putting my x first. So the first thing that came was 2 people tenths. So my x value was 19. Thus, we have the answer here is C. Now, I'm going to show you an alternate approach. Let's think like if we had all 4 people tenths. And there was, so let's say we know we have 60 tenths, and the rest hold 4 people. So let's say if we had 4 people in each tenth, that would be 240, right? But, and that's a big but, we know there was only 220 people, okay? So let's say if there was, so let's think, if you take each total and subtract, get 38. So this would be the difference. This would be what is left over between if every person was in a 4-person tent and all those 4-person tents were at capacity. However, they were not, because that was impossible, because the total number of people was 220. So that means that 38 people were left over. How many 2-people tents were there? How many 2-person tents were needed? Well, it would be what is left over divided by 2. Again, we get our same answer. So these sort of problems, you don't need to remember those, and that's why I said that. That's why I said in the beginning of this problem that you didn't really need to remember how to set up that equation, because these problems can always be figured. But if you do need to solve the system, just remember you're going to have x plus y is equal to a total, and then you're going to have some number of x plus a different number times y is going to be equal to a different total. So these problems are actually really easy to set up, just because, especially on the SAT here, because it's really just a number theory problem, you don't necessarily need this equation to solve it, which is really nice. But if you do remember it, these problems, these equations, these problems will always be accompanied by these equations, by this equation specifically. And then use the elimination method and solve, quite simply. This is a tricky one. I like this problem, but this one is tricky. Because notice, here, I see it. This one's tricky. Look what we have. This is A over B. But what do we want to know the value of? B over A. This is dyslexia's revenge. I'm telling you, this is a really easy problem to get wrong. And I was frustrated whenever I see these problems, because these types of things that to get backwards, I fall for all the time. So always be really tricky at what they're looking for, because it's really easy. Okay, so we have 2A over B is equal to 1/2. So remember, anything that is being under the fraction bar is what's being divided. So this is 2A divided by B. 2A's are being divided by B. How can I get rid of this 2? I want to know what AB is equal to. Well, this is 2 times A. 2 times A divided by B. I want this 2 to go away. So what am I going to do? Well, how about we divide both sides by 2 or multiply by 1/2? Those two things are the exact same. So my 2's go away on the left. I'm left with A over B, and that is equal to 1/4. But, and that's a big but we want to know, remember, we want to know what is B over A. So B over A is actually 4 over 1, which is just 4. So our answer here is sneakily D. And notice what they did here. They put 1/4 first. They put it there first. They're out here trying to play you. They always do stuff like this. This is a test-taking technique, and that's a mouthful to say. Oh, bunch of words. But for real though, this is a test-taking technique where they're out here putting the bait there for you to get, oh, A over B 1/4 right there. Boom, I'm done. But really, like, the right answer is D because it's B over A, which is 4 over 1, which is just 4. So this is the SAT. A lot of times, especially in this math part, it's a lot of brain work. It's a lot of, do you read the directions? Are you paying close attention? Because those types of skills are looked at as more higher order functioning, deeper knowledge stuff. So just look really careful because this is the easy one to get wrong. And I would hate to see anyone get a problem like this wrong when it's basically a layup. Okay, so functions. This might look scary because there's a lot of trash up there. There's a bunch of grossness going on, but I'm just going to try and make it a little bit less gross. Let's say, for example, this is a big piece of junk, and how about we just call it A. A, not junk. A is a nice letter. It's the first one. It's very nice. It's very fine. A is a fine boy. It's a nice letter. What nothing wrong with A. Let's change this to A as well. Okay? So now h of x is equal to 1 minus A. And 1 minus A is a little bit easier to look at because we know that then h of x is equal to 1 minus 2x minus 1. So notice, this is the word is. So g of x is 2x minus 1. So that means that A is 2x minus 1. I'm just going to dump it in there. And now it wants to know, what is h of 0? So let's see what happens here, because this could confuse some people a lot of times. What is h of 0? What changed from here to here? Well, the x turned to 0. So let's see what changes from here to here. The x turns to 0. 2 times 0 is 0. So we're left with minus 1, because this thing goes away. 2 negatives make a positive. This is 2. h of 0 is 2. So what I like to do here, whenever I see a bunch of grossness, is I just try to make it less gross. Just try to clean up the junk, right? G of x was disgusting. Let's just think of it as a different thing, something that's less gross. Let's just think of it as A. And now it just looks a lot better. It makes a lot more sense when we look at, if A is 2x minus 1, then h of x is 1 minus A, so it would be 1 minus 2x minus 1. Just remember that whenever you're doing this subtraction here, that this is actually 1 minus positive 2. This is actually 1 minus positive 2 minus 0. And I cover this in my Essence of Algebra video, but whenever you're subtracting a number, always think of it as, so even 1 minus 2, think of it as 1 plus negative 2. This way, whenever you do a computation like this, it actually becomes a lot easier to see that the result will be 1 minus minus 1. And notice, if you didn't see that, you would have 1 minus 1, which is equal to 0. And look what came first. The wrong answer. In the same spot, too. B is in the same spot as it was last time. But our correct answer here is D. It is 2. So, again, don't just go gung-ho at these. This is a super easy question, but it's asking you, can you deal with 2 negatives in a row? Can you deal with multiplication of a negative number? Do you understand what it means for things to be subtracted? And a lot of people, straight up, just don't. And they're going to fall for this trap. They're going to see B there as that low-hanging fruit, and they're going to scratch in that thing and just, boom, move along. Don't be that guy. Okay, so again, this is going to be our factoring problem. And notice, this is already set to 0, so the one that we saw before this was a lot more involved. But this one I think is actually a pretty easy question. So we have x squared plus x minus 12 is equal to 0. Anytime you have a quadratic, you just want to look at the integer value here, whatever constant this is, and think to yourself, factors of this that add up to that. Factors of negative 12 that add up to positive 1. Notice here, there's a really sneaky 1. This is 1x, right? And so factors of negative 12 times 1. So notice, negative 3 plus 4 is equal to 1. So when I factor this, I'm just going to dump these in here. X minus 3, x plus 4. And what this is saying is, this is multiplication. 2 things are multiplying together that equal 0. So this is equal to 0, this is equal to 0, or both of them are equal to 0. It has to be. So we have to think about, okay, what makes this quantity equal 0? What makes this quantity equal to 0? So some number minus 3 is equal to 0. That number's 3. Some number plus 4 is equal to 0. That number's negative 4. But oftentimes you'll just see them break this up into a very simple equation, which is just what I said. Some number x minus 3 is equal to 0. That number is 3. And the solution over here is negative 4. What this says, if a is a solution to the equation above and a is greater than 3, remember, we want the solution a to be greater than 3. So remember the crocodile, not greater than 3, greater than 0. We want the crocodile to eat. We want the crocodile to eat the bigger number. So the number must be bigger than 0. What number is bigger than 0? 3. The correct answer to this is, here's again, a really easy question. Oh man, algebra is so easy. When you know at a little bit of what you're doing, algebra is so easy. If x is equal to 1, what is the value of a? So some people might see this and be like, whoa, we have too many variables. I don't know what to do here. But they're telling you that x is not a variable. X is a number. X is 1. If x is 1. So just rewrite this. X is 1. Then what are we going to do here? Well, I'm going to subtract this from both sides. We have negative 1/2 a is equal to negative 1. Now multiply both sides by negative 2, right? Because the opposite of negative 1/2 is negative 2. So I'm just going to get rid of that. And so these two values cancel out. A is equal to 2. Just the easiest question. Should thank somebody if you get a question like this. A deceiving question. This is weird, because right away you can see that this isn't really even asking you about math, which is frustrating. It says there are 2 hydrogen atoms and 1 atom of oxygen in a molecule of water. Okay, so that means that the ratio of hydrogen to oxygen is 2 to 1. How many atoms of hydrogen are there in 51 molecules of water? Well, hydrogen is 2 times more than oxygen. So if there's 51 molecules of water, that means there's 51 oxygens. And this is a ratio of 2 to 1, so that means that there has to be twice as many hydrogen atoms, so 102. Deceivingly easy. I mean, seriously deceivingly easy. Do you know what a ratio is? And again, this is like 6th, 7th grade math. So for some of you who are in 11th, 12th grade doing calculus, pre-calc, it's been a long time since you saw this type of stuff, but don't be overwhelmed. Just use common sense. It's a ratio, 2 to 1, right? There are 2 axioms for every one. So yeah, this is a simple ratio. If there's 51 molecules, that means there's 51 waters. So 1 to 1, because that's 1 to 1. Because these two would be 1 to 1, and this one just is 2 to 1, so it's just double. Don't get yourself all worked up over easy problems like this. Oh yeah, so I know every time I see these problems, the first thing people want to do is, oh, let's do the distributive property here. Raise your hand if you want to do this. Like right away, you're like, oh, distributive property, pow, pow, pow. But take a second, I just smell trash. I smell the junk. And where is the junk? It's in the trunk. And if I'm just looking at this problem, I see junk in trunk, man. Junk in the trunk, junk in the trunk. I'm going to rewrite this as 2 pieces of junk plus 3 pieces of junk, right? Is the junk the same? X squared minus x? Yep. X squared minus x? Yep. So 2 pieces of trash plus 3 of the exact same pieces of trash is how many pieces of trash? It's 5 pieces of trash. And what's the trash? X squared minus x. So now really all we're looking at is distributing here. So 5 times x squared is x squared. 5 times x is x. What you might see oftentimes is like 0x something or like 5x, I don't know. But just remember that these are not like terms, they can't be done. So at this stage, you're just done with this problem. Just look for the junk and see if the junk is in the trunk. I mean, the junk already in the trunk here. They did half the problem for you. It's amazing. And really, this problem would be a nightmare doing all the distributing, combining like terms. You have all these steps where you can kind of mess that up. But without doing any of that, just recognizing where the junk is in the trunk. Okay, put the trash together. How many pieces of trash is there total? There's 5 pieces of trash. Then do the distributive property. Boom, ba, pow. Come on. Jeez. Again, some 7th grade math here. Right? I mean, this is a proportion. Cross product. Some of you might be able to do this type of stuff in your head. So what I'm going to do here is I'm just going to rewrite the problem. And cross product, it's like that. So we have 160x. X is the junk. It goes in the trunk. So what are we going to do here? Divide by 160. X is equal to, this is 1/20th. This is 0.05er. It's a D. Where can this go wrong? I have no clue. I have no clue how you could do this wrong. I really don't. And another reason is because you can take all of these values. I don't. I think one thing you might waste your time is by taking these values and substituting one by one in for x and seeing which one of those is 160. That's kind of why I think they put d last and also made it a decimal instead of a fraction. But overall, I just think that this problem is just so easy that you should have a small party if you see this on your SAT. And this is literally a problem from the SATs. Here's one that gets people messed up. This problem is on SAT, it's on your state assessments, it's everywhere. This is on even on some college entry-level stuff. Do you know how to solve for one variable? And really, it's funny because I see these problems so much in that sort of standardized test prepping that the second I see an A somewhere, I just know, right? It says, what is the value of A times B? So here's A and the eighth term. Here's B and what I'm going to call the bth term. So let's look at what happens here. We have AX, and what are we going to do? We will have to distribute this front term all the way through, right? And so we also have this 3x going all the way through. So what I want to do here is look at what is A times B in this situation. It would be A times B, and it would be x times x. So this would be x squared. Now what is my other x squared term in that whole line of, oh, this would actually be negative x squared. This would be a negative. And so what's my other x squared term? It's going to be this 3 times 5x squared. So 3 times 5x squared is going to be a positive 15x squared. And what is my final x squared term? It's negative 9x squared. Okay, so what number plus 15 is equal to negative 9? What number, I'll just say row, plus 15 is equal to negative 9. This is the problem we're solving here. Now this was negative row. So let's see, minus 15 from both sides, and we have negative row is equal to negative 24. Divide both sides by negative 1. You find that our missing value here that I just called row, just to make it easy, AB is equal to 24. So hopefully you see that what I'm doing here, what I'm doing is, as I know right away, AB, this is one of those tricky problems, and what we want to find is that AB, here's A and B, A times B would be some number x squared. And so what I'm doing right away is looking at those x squared values. Here's another one, 3 times 5 would x squared, negative 9x squared, and this equals sign. And so all I'm doing here is taking this value, this was ax times negative bx. So the negative goes in the front, junk in the trunk, numbers in the middle, 5 times numbers in the front, junk in the trunk, and I'm just taking this equal sign, dropping it down, and then doing a really easy solve here. These problems could be a nightmare if you multiply them all out, and they will take forever. Please remember, just remember the organization of this problem, because these show up, and when you see these done for the first time, or if you've never seen these done, it can take you minutes, like seriously 10-15 minutes, lines and lines and lines. It's a long problem that you don't have to spend that much energy on. Which of the following is equivalent to the expression above for all x is greater than 0? So we're only considering positive numbers here. For what? But whatever. What we want to do here is, notice what's happening here. We got this piece of junk plus number 5. Plus number 5. So what do we want to do here? We want to know which one of these things is equal to that. So we want to know what's, but instead of setting up an equation, all I'm going to do is, I'm going to just combine these terms together. Let's see what happens. We have 2x plus 1 plus 5. And I want to put this one with that one and make them kiss. So I want to, just give them one of Cupid's arrows here. So I'm just going to put them together. So my question is, what is this problem? What is this missing? What is this missing? Well, if I want to put these two things together, this has to have the same denominator, because here the denominator is 1, and over here the denominator is 2x plus 1. So I'm going to have to give this the denominator, But I just can't go multiplying things by denominators just willy-nilly. I got to make it sure that, because notice, look, they're in love. We got to put them together. So I'm not just giving them any old one. I'm going to give them the very special one. What's 2x plus 1 over 2x plus 1? It's just 1, and it's a very special one. Ooh, it's so special. It's very special. So now we have two of the same denominators, and all I need to do is just distribute this 5 to both of these terms. And so I'm going to have 1 plus 10x plus 5, and put that over the denominator, 2x plus 1. Just combine our like terms here. 1 plus 5 is 6, so we have 10x plus 6 over 2x plus 1, and that is the answer D. And notice again, they put D at the end. So if you were going to put up some sort of an equation, so if you were going to just go through and just be like, okay, these two things are equal, you would have a nightmare going through one or the other, and you would be burning time. Timey burning on the dance floor, on the math floor. Stop doing that. Stop burning the time. Think to yourself, what is this asking me? What do you want from me, world? And this is what it is. They want you to put those two things together. They want you to make them kiss. And whenever you put two things together, you got to look for that special one, that number one special one. The special one is just the denominator over itself. So denominator over denominator, it's going to be the number one no matter what it looks like. 7 over 7, 211 over 211, the square root of 98 over the square root of 98. That's that special one sauce right there. The special, not A1 sauce, special one sauce. This is the math club, this is the barbecue, bring your family. Next question. Oh, another solution set, but this time we should be, this time we should have an easier problem doing it. So what are we going to do? We want to know solution sets, and just remember that this is that square root, and so we're going to be careful because we're going to be looking for problems that don't work, or answers that don't work. These are what we call extraneous answers. They're extraterrestrial, where they're not from around here. We don't like them. So out here, I'm just going to write an equation, and I'm going to solve for x. So first thing I do is square both sides, because squares and square roots cancel out. So this is negative x times negative x. I'm writing this very specifically because this allows us to see that what we actually will have here is a positive x squared. And we need to set this boy or gal, or really this person, this nice human being, equal to 0. So I'm just going to subtract these things from both sides. So minus x minus 2. And on the left we'll have 0. X squared is minus, and really what I'm thinking about is this boy or gal, or really just nice lassie here. Negative 2, factors of this that add up to that. Factors of negative 2 that add up to negative 1. Negative 2 factors are, which one of these add up to negative 1? It's this one. And so my factors are, I'm going to have 0 is equal to x minus 2, x plus 1. These two things are both numbers, and so it's going to be 0 is equal to this thing times that thing. So there's got to be some multiplication here. That means this has to be equal to 0, or this has to be 0, or they both have to be 0. So I'm going to solve for both of them being equal to 0. Some number minus 2 is equal to 0. Some number minus 2 is equal to 0. The number is 2. Some number plus 1 is equal to 0. Some number plus 1 is equal to 0. That number is 1. And what that looks like in equation form is just this. And we find that x is either 2 or negative 1. Now we need to check. Tricky alert. Whenever you're making a substitution, x is equal to, let's say, 7, that means that negative x will be equal to negative 7. If you have x is equal to negative 7, then negative x will be equal to negative 7. So this is a tricky alert. Like, you got to be on high alert for this, because otherwise you might think that this is an extraneous solution. So plus just go. So this is the number 1. This is the square root of 1. So 1 is equal to 1. That works. And if that one works, let's test the other one. No, this isn't going to be true. This isn't going to be true. So square root of 4 is 2. 2 is not negative 2. This one doesn't work. This one, the positive answer don't work. What is this graphic? Oh, this one probably has an asymptote right here, or it's an empty. The moral of the story is that we need to, whenever you see these square roots, you have to check your answers, and it's annoying. Like, I totally understand, but that's why it's so crucial that when you have those easy problems, that you have to notice right away, this one's easy, I can solve it, let's use the best method. This problem right here, a little bit tricky, I have to take my time, I'm gonna have to check some answers. So this is the problem where if you're gonna be doing time management, you gotta put a little bit more resources into a problem like this to make sure you get the right answer. And notice how similar all these stinking answers are too. So really, like, you really gotta check to make sure that what you put down there is the right thing. That's why, again, it's so important to use that resource management when you're doing all those other problems. This problem is super tricky, I see it already. Wow, okay, so let me think. I want to think to myself, what is up with, how are these two things related? Can you see it? What if we multiply both those by 2? It would turn into the problem below, right? So what can we do here? We can factor out. But once you see that this is actually twice the original problem, and it really, if you don't even have to think about that. You don't have to do all this work. If you can just recognize that this expression is twice this expression, right? That 2 of these are those, that this one is double, then if this one's double, then the answer, and the answer is 4, then this one would be half, which means the answer is 2. This is just a scale. So, man, I like this problem a lot. So there we have it, a bunch of easy algebra problems where I think that sometimes the simplicity of a lot of those problems are really what trips us up. And it's because a lot of times when we're taking the SATs, we're preparing for the SATs, we're preparing for the harder stuff. We're preparing for the things that are more difficult. And we kind of forget that algebra is actually super easy. And just kind of remember that, to remind us of that, I actually have a series of the essence of algebra where I just look at sort of that basic idea. So I'll link that in the description below. But as always, hey, I really appreciate you guys checking out this video. And if you're new to the channel, get that subscribe button. That subscribe button and give it a big old thumbs up for me, please. It really helps me out. But either way, I really appreciate just checking out the vid. I'm out.